Okay, so now if we roll back a lot earlier in the semester, so as we've kind of gone through things, we started at a high level and we just keep dropping down just a little bit, just a little bit, just a little bit. So as we kind of start wrapping things up, we want to go almost all the way back to when we first started talking about memory. We were talking about registers are the really fast memory, and then we get to caches and system RAM, and trying to get an idea on what memory is fast and what memory is slow. But we never really talked about the technology underlying those individual memory types. We just kind of said fast memory tends to be smaller, slow memory tends to be larger, and that's just cuz, right? That's kind of the deal. So this is going to kind of break it down a step further, and the book talks about it in really three different levels. This magnetic disk thing is just giving us our baseline, and really anymore, the whole thing about a magnetic disk is kind of going away, isn't it? I mean, several of us probably still have computers with a mechanical hard drive in it, but if you bought a new computer today, it would be difficult, I think, to find a brand new computer today that had a mechanical drive in it, unless you were going desktop and the real budget pleaser, right? I mean, even a lower end laptop today typically is going to have a relatively small solid state drive in it. And if that's not 100% a true statement today, we're not far from it being a true statement. All right, so this idea of a magnetic disk, so our 2 and 4 terabyte hard drives, those are all going to be mechanical drives with a spinning disk and a read-write head and all this stuff. So to kind of give you an idea on access time for these things, notice that it gives you access time in terms of nanoseconds, but it also starts giving you price breakdowns in gigabytes. All right, so this is from 2012, but so it's probably a little bit cheaper now than it was then, but you can translate this out to how much they are relative to each other. So, for example, what's considered, if we kind of talk about hard drives for a few minutes, if you go out and you get a new laptop that has a solid state drive in it, what size drive is pretty common for a laptop computer today if you get a solid state? Probably 256 gigabytes. You could probably upcharge to maybe the 512. Outside of that, you start getting into some pricier dollars. 1 terabyte drives exist, but they're pretty expensive. I would say a year ago they were prohibitively expensive. Now they're almost prohibitively expensive. There's a pretty big jump to go from 512 to a terabyte in terms of dollars in solid state. But you might be able to go from a 256 gigabyte solid state drive to a 512 solid state drive for $100 or something like that. It might not be ridiculous. All right. Now, why do we do solid state? So, how many of you have solid state hard drives in your machines of some kind? Okay, why? Why solid state?
Because it boots up a lot faster.
Okay. Okay. So now, how many? Let me take it one step further. How many of you have 2 hard drives in your machine, or 2 or more hard drives in your machine, a solid state and a mechanical? Okay, why do we? Oh, so we'll stay with you. Why do you have both?
Well, you install the OS on the SSD, the computer boots up in like 30 seconds, and then you store all your data on the hard drive. You don't really use all that much, but it's a lot more space.
Okay. What about applications? Your video games and stuff like that.
Store most of them on the hard drive, the
Mechanical drive, okay. So let's say you have a video game that you play pretty often, whatever the game is, game XYZ. What would you gain by having that? So you started off with kind of this argument that you have to pick and choose what you install and what, because obviously your solid state drive is substantially smaller than your mechanical drive. So what's the size difference? What's your solid state versus the other one?
I think it's like 250 on the SSD and 2 terabytes on
the. Okay, gotcha. So 8 times smaller, right? So it's roughly 8 times smaller. But 250 gigabytes is plenty to store an OS plus some other stuff. Do you have anything else on that drive?
Some video editing software, I think.
Okay. Okay, gotcha. But not your games.
Really?
That's interesting.
Space.
Huh?
Not enough space.
But if you have a
You can put
250,
one or two.
yeah.
I tried putting Skyrim on my SSD and it was a slightly faster, but it wasn't like worth filling up my SSD for.
Okay, I get what you're saying. All right, so typically what you might do is you might use your mechanical drives as just the garbage dump, right? Okay, Word documents, MP3s, just file storage that you access every now and then. And I mean, when you're listening to an audio file on iTunes or something like that, do you really notice the slowdown of whether it's on a solid state drive or a mechanical drive? It's all compressed. It's all having to go through the CPU anyways. Music is music, kind of that type of thing, right? But now when you're playing a video game and it's running in real time, and it probably depends on the game, and actually, it would surprise me if Skyrim wouldn't drastically increase in speed on an SSD.
What do you mean drastically increase? What do you mean by speed?
Well, I love those questions.
Yeah. You just mean load times, basically.
No, well, not just load time. Also, well, okay. So let me back up and tell you why I'd be surprised. Then we can kind of circle back on it. Certain games do a lot of file I/O back to the hard drive because they're having, and especially games like that are single player games. Yeah. So, back on you don't need an internet connection to play Skyrim, right? So you're playing this game and everything lives on your computer. And whenever, you finish a quest or something like that, whenever something happens that needs to get updated in the game, where, if you quit the game and come back, you don't want to have to redo that, right? It kind of remembers where you left off. There's lots and lots of little checkpoints. Now, Skyrim, if you play for 15 minutes and you don't actually save yourself, if you close the game and reopen it, do you have to redo all that stuff, or is it kind of keep...
Sometimes there's autosave points, but like if you just walk into an area and you don't go in anywhere, then it won't save.
Okay. But so seemingly it's doing something automatically in the background, but there's some clear if you want to make sure that wherever you're at it's saved, you save before you quit, right? That's the thing, okay. But the bottom line is it is doing file I/O stuff in the background, and whether it's direct file I/O or it's writing to the hard drive through a database, through its own database or something like that. These are things that happen in real time while the game is running. Now, games that do a lot of file I/O are going to benefit from running, from being sourced on the solid state drive, because that file I/O will happen more quickly. Games that have a big memory footprint. So if a game launches, so the starting point for a video game on a solid state drive, regardless of the game, is it will launch quicker, right? Because it'll move from your solid state drive into RAM more quickly because they're faster, right? We already know RAM is probably going to be faster than your solid state drive. It's kind of this discussion we're going to be having here. We can see right here, RAM is this DRAM. So our system RAM is this guy right here, DRAM, which has an access time of 50 to 70 nanoseconds compared to 5,000 to 50,000 nanoseconds. So faster, right? All right, then that probably translates into data rate and things like that. So, whatever. Our 8 gigabytes of RAM on our computer is going to be faster than your solid state drive. So the way it works. All right, so if you're loading your game into memory from your solid state drive into RAM, only part of that game is going to actually load. And then as you mentioned something about load times before. So I haven't played Skyrim yet. I bought it. I haven't played it yet. Yeah, so it's that might be my airplane game. Yeah. Oh, and just so in case I didn't, I think I told you guys at the beginning of the semester, but so we have 3 more classes after this, and then final exam week, right? We have Thursday and then next Tuesday and Thursday. Your final exam in here is going to be online on Blackboard.
What?
Is that bad? Is that good?
No.
They're all going to be really ambiguous questions.
No, it'd be kind of the same test, the same as usual. Just I won't physically be here because I'll be in the ocean.
Take it at the time on the day, like.
Okay, where do you take it? Yeah, I'll put it up there. It'll probably be due like Sunday night after final exam week or something like that. because I just have to have the grades in, I think by Tuesday, and my cruise ship doesn't come back until Sunday afternoon. So typically I wouldn't go on a cruise in the middle of final exam week, but my brother had planned this big family cruise 2 years ago with his kids. So it's a free cruise for me, first of all. So it's a Disney cruise that so we're going on with my parents and my brother and his family and his 2 children, that's the cruise is for. So it's a family gathering thingy. But I get a free cruise out of it. But that's where I'll be during final exam week. I'll have some email access and stuff, but I'll have, so what it'll be is it'll be like the normal exam. It'll be put up there. It'll be a timed thing. I'll probably give you some extra time on it. So instead of 2 hours, maybe we'll make it 2.5 hours or something like that, just in case there's some quirkiness with trying to get the thing working. Or maybe I'll just make it like 4 hours, like double time or something, because I don't really care about the time. And then you sit down, you got to do it in one sitting, and then you submit it, and that's it.
So you're making it open note then, or?
Well, I mean, I won't officially make it open note, but you have the amount of time. I mean, nothing necessarily keeps you from looking at the stuff. I mean, I can tell you don't look stuff up, but I mean, I'm not going to know that you did. So, I mean, what I want is to see what you know. I mean, so the idea is that the exam is not going to be like, regurgitate stuff like what's the definition of ABC. It'll be to solve some problem. So even if you reference your notes, you're still going to have to solve the problem. So I guess just to make things easier, I'll probably just say, yeah, it's open book, open note, but you're still under the time period. So that might help you, that might not. But in any case, it'll be fair. I'll give you plenty of time and all that stuff, but I just won't physically be here. So it's the thing. Yeah. So yeah, my flight leaves at 4 p.m. a week from Friday. And then I'll be back on January 22nd.
Oh my gosh, you're gonna be here for like the first week of school.
I'll be here the first week of school.
That's crazy.
Because January 22nd is the Monday, right?
Yeah.
My flight gets in at 11:45 p.m. on Sunday.
Wow.
Yeah.
That's crazy.
Crazy, you mean awesome.
Yeah.
I was mapping out this morning from my condo in Florida to the main door to the golf country club down there is a 4-minute walk. So I'll wake up every morning.
For a normal sized person.
Well, I mean, I'm going to have people that will kind of piggyback ride me there. Okay, so I'll wake up when I wake up and then just walk over and golf all day and then come back. Go to sleep. And same thing every day.
So what are you gonna do for Christmas and New Year's then?
Well, we're going to be in Florida. Whatever my wife wants to do.
Celebrate Christmas there?
Yeah. My grandma's down there, but she's Jewish, but I usually get a Christmas present from her anyways. So it's always good to get a Christmas present from a Jewish grandma.
Socks.
Nah, she usually gets, I'll at least get a dinner out of it or something. Yeah. So yeah, I think I'm going to some musicals.
Like what?
My wife invites me to them. I just accept it.
Oh.
I think I'm going to Cinderella and maybe
Facebook invite.
Titanic. No, I mean, I get the count. She's in charge of my calendar. Yeah, yeah. Those things are completely out of my. I think I'm going to some painting night.
Oh,
I think we're.
exciting.
I don't know.
I'm excited to see your painting.
They're not bad. I got 2 paintings in my office that I made at these painting nights.
An original Lippmann?
Oh, you haven't seen them?
I know I saw one of them like
I have Teenage Mutant Ninja Turtle heads on it. Yeah, I mean, you're supposed to like an artist is up there and they say, okay, well, to get here's what the final painting is supposed to look like.
You drink wine and mimic the painting. Basically.
I drink a lot of wine, yeah, and almost start mimicking the painting, but I go off script real quick. Yeah, my wife tries to make it look the same and stuff like that. I'm mixing random because I don't know my colors very well.
Right.
You mix this color and this color, I don't know what it turns into. So I just smear the stuff together and then I see what it looks like and then I make stuff out of that. No, and then I drink a lot. It's all recorded. Yeah, so my condo's 4 minutes from the golf course and I think it's a 5-minute drive to Skyline Chili. Yeah, it's fairly legit. Yeah, Fort Lauderdale area. See, it's going to be 20 degrees here, and I'm going to be dealing with sunburns.
In places that way.
One night I'm just going to sleep on the beach. You're allowed to do that, aren't you? Or do you get like arrested? I mean, I don't want to get arrested. It'll cut into my golf time, but I'd like to sleep on the beach sometime.
Good story though.
Huh?
I said that'd be a good story.
All right, what were we talking about? How do we even get onto that story? Oh, I was telling you about the final exam. That's right. Okay. So in any case, our system RAM is based on this DRAM semiconductor memory, blah, blah, blah. We'll talk about kind of the details of that. We'll start talking about the details of that today. And then we have our flash memory. So we can certainly see between the two of these guys that flash memory, our solid state drives, a lot slower than our system RAM, right? Faster than our mechanical drives, but a lot slower than our system RAM. So if you have a video game and when you launch that game, when you double click on it, you know, what's happening under the hood in our computer? Okay, a portion of that game. So what if you had to describe, if you were to look at our game at the 20-foot level, what does our video game look like on disk? What are the components of a video game? Okay, so a bunch of textures, pictures, and stuff. Okay, so a whole bunch of graphics. Okay, what else? Okay, so then compiled code, so binary stuff. So a bunch of zeros and ones that translates into something in the assembly language of the architecture we're on. So if you're dealing with Skyrim, I think it's Windows only, right? Well, in consoles, but the Windows Skyrim, that's the one I downloaded. So that's going to already be pre-built for the Windows system calls, right? You know, so it's going to be compiled for Windows API system calls and the Intel architecture. So all the code will be already in that format. All right, so a bunch of code, zillion zeros and ones, a bunch of textures. Anything else? Yeah, just music, all the things we see in here, and then all the logic stuff. So interface, logic, okay, and then you might have some back end type of backup stuff and some networking code. We'll just throw that into the big category of code stuff. All right, so if we think about our game sitting on disk, it's effectively a pile of code and a pile of graphics and stuff. Okay, so when we double click on that game, what needs to be, we operate out of RAM in our computer, right? Well, RAM is we operate off of RAM more readily than we operate off of our hard drive. So when we double click on that, the Skyrim icon, it's going to load some aspect of that game into RAM because our CPU feeds off of RAM, right? And we talked about pipelining a little bit already, right? Okay, so we have this idea of pipelining. How do we keep the CPU fed, right? We have RAM, we have the current application we're working on. How do we keep stuff streaming out of RAM and keep it filled up over here so that our CPU doesn't have downtime? It's not sitting there, like trying to eat and there's no food there, and then the dog gets mad, he bites somebody, right? Okay, we can't have that. So that's what pipelining is how can we efficiently get stuff from it. So pipelining is kind of like buffering for Netflix, right? You want to get the stuff filled up enough here that, we keep it filled while the CPU is eating, all right? Now, what aspect of our game needs to be loaded into memory? Because how big is a Skyrim on disk? Give me a ballpark. 30 gigs? Is that not an unreasonable number?
Yeah.
Okay, so 30 gigabytes on disk. How many? I think one person here could house that in RAM, right? Who can house 30 gigabytes of stuff in RAM? Just barely though, right? That plus OS is going to be close. Because what are you, 32 gigs? Yeah, it would be tight. You'd be having to use swap space a little bit, but for most of us, we're not loading a 30 gig game into RAM, right? Now, would we want to? If you could, would you want to? I guess that's kind of a loaded question. Depends how easily we could accommodate it, right? It's like, could I fit into a Prius if I wanted to? Yeah, I've been in a Prius, but it's like jaws of life to get into it. okay, and jaws of life to get out of it. But once I'm in, it's kind of comfy, right? So, but I take up the space is the point. So if you had plenty of extra RAM, so if you had 256 gigs of RAM, maybe you'd be willing to set aside 30 gigs to have an ultra fast game just in RAM, right? That would be a reasonable enough thing, but we don't have that yet. And realistically, when we get to the point where we maybe would have that 30 gig game is probably going to be 200 gigs, right? Because the textures get bigger, blah, 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 all this other stuff. Okay, so we're not going to load that entire 30 gig game into RAM. So what do we load into RAM? What do we need to be able to play that game? I mean, when you sit down to play Sky, how long does it take to quote, beat the main storyline of Skyrim? 30 or 40 hours? Okay. So what do you need for the first 5 minutes? So take me through whether you Skyrim or some other game. When you start playing the game, it's usually, kind of a little, intro cutscene, the makers, whatever, blah, blah, blah. Then there might be a login thing if it's an online game. Otherwise, there's like there's a menu for starting a new game, continuing in a previous campaign, all that kind of jazz. And then you're kind of in like the level 1 area or something like that, the starter area, right? Maybe it's the center of town. I don't know what Skyrim is, but something like that. So there's a much, much, much larger world than what you initially are aware of in a game like that, right? Is that fair enough? My understanding of Skyrim is the world's giant. Is that correct? Okay, so I'm just excited to play this game eventually. It's really hard to play more than one game. Really? I think it's because I play World of Warcraft. It's hard to keep up with the Joneses in World of Warcraft while dedicating any time to anything else. Sleep, food, just anything else. All right, so some percentage of that game is going to have to get loaded into RAM. Now, you mentioned something about load times. How are load times experienced in video games? Keep telling me about Skyrim because I'm interested.
You enter a specific area like a house or a cave or something, and it goes to a black screen, gives you some tooltip, shows a model, and says loading.
Okay.
That's if you like fast travel to an area.
Yeah,
Just
same with
walking
fast
from
travel.
an area, it loads it as you're
Okay.
approaching it.
So let's do the fast travel thing. They're both kind of the same thing. The fast travel thing gives us the idea of it's having to do in real time what it previously was doing while you were traveling there, right? So the real time will make us feel this in a more realistic way, I guess. Okay, so I was in the main town, let's say, and all that stuff's already loaded into RAM. So that's the textures for the main town, any music, things like that, any multimedia crap that's playing, all the logic for all the different NPCs that are, the computer guys that are wandering around the main town, that kind of stuff. All that stuff is loaded into memory because that's readily necessary for what's going on around you right now, right? Okay? So now you fast travel to a place across the world, some other place. So now you're there, and what happens is there's a cutscene or a pause or something like that, and they give you some nice little. It's almost like elevator music, right? Okay, it's the equivalent of being in the elevator and waiting to get to the 17th floor or something like that. Okay, so you're sitting in there while the graphics, the textures, the multimedia, all that crap needed for this new scene are moved from the hard drive into RAM. While the logic, any new logic it needs, there's going to be some logic subroutines that are going to be consistent throughout. There's probably a generalistic monster AI that's kind of in there that's always in RAM, but there's going to be maybe textures for the specific bad guys or not so bad guys in that area that you're about to go to that are going to have to get loaded in. If before you were in town and now you're in the dragon den or something, there wasn't a whole lot of dragons wandering around in town. Or maybe is there dragons in town? Oh, I love that. Isn't there a lot of dragons in that game, right?
Dragon Slayer, so.
Yeah, I didn't know that, but I knew there was dragons. I love dragons. I mean, I love killing dragons.
You don't just kill them, you absorb their souls too.
Oh, yeah. Now, if you die, can you like go back and start over where you like the last you were alive?
Yeah, it's like checkpoints.
Oh yeah, so I'm like good. Huh.
You can save anytime.
So like right before I fight a dragon and try to drain its soul, I should save.
Yeah.
That way, if I die, I can decide whether I should do this again or if I have to go level up. So right?
Yeah.
Yeah, you gotta save at the right point because you can get stuck in an endless loop there. If you save and that dragon's there, and
Oh, you might revive and you're already in the fight,
yeah,
and you can't run away. Run away.
Yeah, you should usually be able to.
Because isn't that the way it worked, like in the original Final Fantasy? Have many of you played the original Final Fantasy, like the actual original one?
Yeah, like you could save like at a point where it was like, like it would be like unavoidable for you, but like you can save it like
Yeah. Well, I guess what I'm thinking of is just the whole idea. I'm assuming this is the same thing where you would fight a monster, and if you couldn't get past that, you would just go back and you would just run around farm until you got a higher level, and you go and fight him again.
You can pick up your stuff when you're dead. Just like Diablo.
Well, I have to go pick my stuff up.
No, there isn't a. It's just a respawn. There's no respawn. It's you die and then you go back to the checkpoint.
What I want to be is I want to be invincible and I want to absorb dragon souls.
Till
you
the
mod.
God
Well,
mode,
the
not
dragon
kill
mod.
Yeah.
When the dragon, well, you don't press F5.
All right. Let's get back to our memories now. See, I got off track with this whole absorbing dragon souls. All right. So when we get to this new area that we haven't been in previously, the new assets that are part of that area get loaded off of disk into RAM. So at any point in time, our footprint that game is taking up in RAM is significantly smaller than the total install size of that game, right? It's going to depend on the game and the size of the textures and things like that as to, how big that footprint might be, whether it's 1 gigabyte or 2 gigabytes or 500 megabytes, whatever it is, okay? But typically the games that are really pushing your system are going to have a larger memory footprint than some of the other games, right? And the same thing goes, you mentioned that you have some video editing stuff on your disk. So when you're doing rendering or something like that, you're using a lot of scratch space, and so it's doing some things in RAM and some things on disk, and then moving things from disk to RAM. It's using a lot of system resources while it's doing that. Okay, so those types of things are going to have a pretty big RAM footprint as well. All right, but kind of sticking with our video game example here, the bigger the game, the higher resolution the game, the newer the game in most cases, the more system resources it requires, right? So typically it's, this guy needs the fastest processor or a faster processor. He needs a lot of RAM. He needs a lot of graphics horsepower. Okay, where does your graphics card come into play? What do we need that for? What do you need a super fast GPU for to make your game work well? Okay, tell me about rendering textures. How does that work? So we got some textures in RAM, right? So we got some stuff loaded into RAM. Now these are bits, right? So this is the zeros and ones that make up some crazy high resolution image. Now when we think about that, when we say high resolution today, what does that mean? High resolution is a constantly moving bar, right?
4K.
Okay, so a 4K game today might be the highest resolution we might expect. Okay, so 4K is what resolution? 2048 by 4096 or something like that. So I think the actual.
84 by 21. Yeah.
Oh, so that's not true 4K. That's 4K relative to 1020p or 1080p rather.
So then it would be the 768 by 4,000.
Okay, so 3840 by 2160 isn't quite true 4K. That's just the Ultra HD, but that's fine. We can work off of this. So this is 4 times the number of pixels of 1920 by 1080. So if you took that, multiplied by 4, it should give you this number. That's where they come up with the whole 4K thing. But this is a pretty high resolution, so we'll operate off of this. All right, so that's 3840 times 2160. So that's 8,294,400 individual pixels. Right? Now, each of those pixels is going to have some color associated with it. Okay? And let's just say that the color is 24-bit color. Is that pretty standard now for games, you think? 24 bits? Okay. So that's 24 bits. So that means to have a static picture, full 4K, is 199,065,600 bits of data. Okay? So let's kind of put that into something that's a little bit, so we'll divide that by 8, so that's bytes. We'll divide that by 1,024, that's kilobytes. And we'll divide that by 1,024 again, so it's 23.7 megabytes for a static 4K image at 24-bit color. Uncompressed. Okay. Realistically, most of the images, if you just see a static image, are more than 24-bit color. But in a game, 24-bit color might be the normal thing. So we can operate off of this for our example here. Okay. So now, when you're playing a game, how many pictures show up at a time? 60 a second? Okay. So we need to multiply this by 60. All right, so that's 1,423 megabytes every second. Okay, and that's uncompressed. So if you, most textures are going to be compressed values that then need to be decompressed by the graphics card. So that's where the GPU is really working when it comes to rendering textures. When we're saying rendering textures, what we're really saying is we're going to take a compressed format where we can have a lot of data stored in a small bundle, and then we're going to rely on the horsepower that we have to, in real time, decompress that and get it onto the screen while maintaining 60 frames a second at some ridiculous resolution. Make sense? All right, so and then that isn't even taking into account shades and shaders and cameras and all sorts of other things. So this is just graphics. All right, so with that in mind, if you get to a game, a lot of times what you can do to increase the performance of a game is to reduce the resolution, right? Reduce the resolution, that means you have a fewer number of pixels that you need to make show up on the screen. So instead of, if you have a 4K monitor, just to keep things simple, instead of every pixel on your screen being related to every one pixel in your texture, in your image, now you can have quadrants of the screen equal 1 pixel. So you don't need to have as much data to get a picture that the human eye might think looks almost as good. If you've ever seen a 4K image, and then right next to it you saw a 1080p image, so Ultra HD versus standard HD image. If you look really close and you're looking at very specific things, you can definitely see the difference, right? But at a glance, depending on what you're looking at, sometimes the difference isn't so huge. Okay, a lot of times what the Ultra HD proponents really focus on is the amount of detail that exists in the picture, which is often different than the amount of detail that a human being actually notices. Those are two different things. Go ahead.
Is there a point where the resolution doesn't matter to the human eye, where it just looks exactly the same?
Well, not if you're the doctor. But resolution is a different thing. I would say probably not with resolution. Definitely with frames per second and pixel density. So, the human eye is always going to be able to appreciate more and more detail as long as we have enough space to experience it. So where things are going to start breaking down for us is if we get very, very, very high resolution in a very physically small space, which means that our pixel density is very small. So when you think about on like our phones and stuff, the Apple has their thing, the Retina display, right? So the Retina display deals with how many dots per inch you see on the screen, because the human eye can't differentiate pixels if they're too close together. Okay, so if you went back and you looked at the first iPhone that had the Retina display was the iPhone 4. So if you went back and looked at an iPhone 3GS and you looked at the iPhone 4, what I would usually have people do back then was open up the keypad like you're going to make a phone call and look at the number 2 On the 3GS, you can definitely see individual pixels for the 2. If you look at the 4, you won't be able to see the pixels. And anybody in here who has a newer phone, iPhone or not, I mean, Apple calls it their Retina display, but these are screen quality things now. If you open up, if you have a newer smartphone and you open up a screen, go to like the dial pad or something like that, and you look at one of the numbers, you will not be able to see the pixels. Your eyes aren't good enough. Okay? You can't differentiate this pixel from this pixel right next to it because they're squished too close together. Make sense? So those are things, when we get to pixel density, that you get to the point where the human eye can't appreciate it anymore. Things are, sharp is sharp. Now, having said that, and I think he pointed out one time this situation where there is a feeling of kind of smoothness at 120 frames a second versus 60 frames a second versus 40 frames a second. So even if we say the human eye can't necessarily detect the difference, we can't see more than 40 frames a second, let's say, or 44 frames a second, depending on who you talk to. When you're experiencing 120 or 150 frames a second versus that, you have a feeling that it's smoother. So you might not necessarily be seeing every frame, but the experience you're having is it is smoother. So higher frame rate typically will mean better human experience, whether you're perceiving all of it or not. So then what do we need to do? If we're going to keep making it bigger and bigger and bigger resolution, we need to make it fill up a larger physical space in order for human beings to appreciate the detail, right? So, if you make the iPhone screen 4K, let's say, and I think there's Samsung's newest thing, I think, has a 4K screen on it, right? The new iPhone does not, but I think at least a couple of Android phones have a 4K display, or at least a 4K camera. Maybe I'm lying about the display.
Galaxy S8 will be the first Samsung phone with a 4K screen.
Okay, but the point is now you have a phone, even if it's a larger screen size. So like this guy here, this is your 5.5-inch screen. To get that many pixels into a 5.5-inch screen means that your pixel density needs to go to some ridiculous number that's way beyond what the human eye can see. So you're not going to get all that you should get out of that 4K screen. You're going to get a whole lot more out of a 65-inch 4K TV showing a 4K picture than you will out of a 5.5-inch screen showing a 4K picture. Because things are just too close together. The detail is going to end up being lost on you because the pixels are too close together. Okay? Where if you look at your TV, you can, you can't see the whole screen at once. If you're standing right up on it, you can actually view the differences in detail and that kind of stuff. So where there's space, we can benefit from it. Okay. So, yeah, this is always an interesting picture I've shown before. So if we kind of look at the history of kind of our screen resolutions, you see that 4K here is 4 times the pixel density of 1080p, or not pixel density, 4 times the number of pixels than 1080p. This is Blu-ray, 1080p. Although haven't they just started calling the 4K? They call them 4K Blu-rays. Don't they still call them Blu-ray? Which is really dumb to me. Because in the early days of high-definition DVDs, you had HD DVD versus Blu-ray, which is a Sony technology. And Blu-ray won, right? You don't see HD DVDs anymore. So Blu-ray is a brand for true high definition, 1920 by 1080 resolution. So to say 4K Blu-ray doesn't make sense. No, I think the technology is different.
I thought it referred to the disc.
It does,
Yeah,
but
so
the discs are different.
But so why does a Blu-ray disc only able to hold a 1080p image? Why? I thought the Blu-ray just meant it was able to hold much more data, so it could hold the larger things.
Absolutely, but to a maximum size.
Sure. So what you're saying is they made better discs and kept them Blu-rays, but they're now 4K.
That's it. Yeah, they could hold.
Well, they did that for marketing.
Yeah, to hold a 2.5 hour movie at 4K is going to take more space than your historical Blu-ray disc can hold. So they just call it a Blu-ray still, but it's a whole different technology. That's why you can't just plop it into your old Blu-ray player.
Oh, really?
Yeah, you
Can't
need a
just go plug it
no,
in.
you need a 4K Blu-ray player that knows how to deal with the new discs. I mean, you can hook up a historical Blu-ray player to a 4K TV and watch it at 1080p. But I don't think you can put in a 4K Blu-ray. In fact, I'm positive. Let's call it 98% positive that you can't put a 4K Blu-ray disc into a 3 or 4 year old Blu-ray player and have it work. It's not going to know how to read the disc. The disc is a different technology. It's a quintuple layer, 9 laser type type of technology. I don't know.
They sell Blu-ray players that have it as 4K Ultra.
Yeah. Yeah, it's just, and then you also have to be careful with that because there's going to be some of them that actually are able to handle the 4K Blu-ray discs specifically, and there's going to be other ones that will do hardware-based upscaling. So it'll take a 1080p image and upscale it to 4K. And we're all still talking about kind of the same stuff as the video game discussions. We really haven't gotten off topic. We just kind of switched our example here. If you do that, if you're upscaling an image, what you're doing is you're looking at a quarter of the pixels. So a 1080p image has 25% the number of pixels as a 4K image. So what you're doing is you're going to explode each pixel out 4 times. So you're going to look at the relative color of this pixel and turn it into 4 pixels of similar color. But you want to have meshing, so you don't have this block thing. You want to have, if this pixel here, if from here to here to here to here to here gets a little bit darker, you want to mesh that through the new pixels you're entering in the middle to upscale with quality, right? So I don't know, it's interesting stuff, but that would be kind of the fakey 4K thing. When you go to buy a 4K TV, they talk about, it'll upscale your current content. That's fine. It'll look a little bit better, but yeah.
So if like you're watching a 4K TV, or a 4K image or whatever, are you literally seeing 4 times the image than a 1080p?
As long as the signal is 4K, yeah.
So you're seeing more.
Yeah. Yeah, more data is there.
Well, I mean more of the picture, so is it extra wide?
No, so yeah, so let's say you take a picture. So I have a 1080p camera here, and I have a 4K camera, and I put them both on the same tripod, so we're taking the same, and the lens has the same coverage. All right, that 1080p is going to take a picture that looks good. The 4K is going to take a picture that looks good. If you were actually to explode that picture out, you can go 4 times larger with the 4K without adding any blurriness, because there's 4 times more data that was collected from that 4K camera than there was from the 1080p camera. Now, because there's 4 times more data, that means 4 times more detail was collected. Now, some of that detail might be meaningful. Some of that detail might not be meaningful to a person, right? If I'm collecting 4 times the amount of information about this white wall here in the back, does that really mean anything to me as a person? Do I really care that, there's a little spot up there that has aged a little bit differently than the spot next to it? And that 1 pixel, it's really changed my view of this room, right? Something like that. But now, those are things we might not care about. But when you're actually talking about individual detail, like for instance, if I do a wide scan of this, a 4K image might pick up some of the details in the stickers on the back of his laptop, where the 1080p, that might be harder to make out because there's less data for it to work with. Does that make sense? So not all 4K images are created equal. If you take a 4K image of a glass of water, you're going to get less out of that than if you took a 4K image of a crowd of people waiting to get into a concert. Okay, a 4K image of people getting into a concert, there's a lot of detail to be captured in that image. Or a picture of a glass of water you're not going to notice a whole, a whole lot of extra detail there. So I guess that's kind of the deal with that. So 4K isn't necessarily always better, but it is always bigger. It is always a larger data stream because the data's there whether you are going to appreciate it as a person or not. All right, so but hasn't that kind of become our, well, I say hasn't that become our society, but that's really just how humans work, right? We always want more. You know, we talked about this with our internet connection speeds, right? You know, what used to be really fast. I mean, I remember waiting in line to get a 56K US robotics modem. You know, to upgrade from my 33,600 modem to the 56K modem. I mean, they just didn't have stock. I mean, you know, it's just like Christmas, you know, when you go to like one of the stores and they give you a number, it's like, oh, we only got 6 of them in. Like you're standing out there in the cold waiting to get your modem. I mean, it's like just like people waiting in line for a PlayStation now, right? This was how to connect to the internet. I mean, you would camp out for a gigabit internet.
No, you're right. I wouldn't do it for a PlayStation or anything like that. I wouldn't do it for a game anymore. I have, but if this was, you know, if this was me going to get my internet, then yeah, I would for sure be camped out.
Yeah, but everybody can replace that example with something, right? Everybody has something that they're willing to wait for. You know, people camp out for tickets to concerts or something. I mean, I would never do that, but I don't like music. So I don't go to concerts unless my wife makes me. So, which happens pretty often, actually. I've been to so many musicals. You know what the worst music? There's 2 musicals that were the worst. They're tied. Worst musical, I think, Lion King. We saw Lion King on Broadway. Super famous and interesting, you know. Way too long. Like the movie is like what, an hour and a half or something like that. Yeah. The play or the musical, it's a month long. Okay, I'm rounding up slightly. Okay. And it's like 4.5 hours. It's long. They take the first intermission at 2.5 hours. Yeah. So I'm in a giant Broadway theater that, you know, you can imagine, and you look at these like baseball stadium stuff where they just try to pack people in. And those tickets are expensive. They try to get as many people in those walls as possible. You know, they're like right at the fire limit, right? So obviously I only take up half of a row. So so I'm sitting on the people next to me. So I have my wife on one side, and then I have the random stranger I'm sweating all over on the other side for 4.5 hours. Yeah. And I didn't even get good food afterwards. My wife's like, oh, I'm kind of tired. I already had my place picked out. I don't even remember that. It was some dessert place. I was going to get some giant, I had like a 4-gallon milkshake. Yeah, it was. Well, I saw it. It looked great. I think I got to go 2 days later or something, but that didn't make it better. That's the problem. We're talking about games, waiting in line. Okay, yeah. So our human nature is that we keep wanting more. Okay, once we get more, we want even more, right? Same thing's true with our computing. Same thing's true with our memory. This laptop is from 2012, and it has a 256 gigabyte solid state drive in it. 2012, 256 gigabyte solid state drive was legit, right? Today, when we ordered the new laptops, and I looked at it, that's the entry point, the 256, and that's like, you know, if you're basically taking out a second mortgage in your house to buy this laptop, then this is your baseline. You know, we don't think you can survive on this, but we'll put it in there anyways. And so really your starting point now is like 512, right? You know, for most laptops. And then if you want to splurge, you go to the 1 terabyte, or if you want to just be insane, you go to 2 terabytes. Is anybody else doing the 2 terabyte solid state drives besides Apple right now? In stock machines? Yeah. I mean, the price increases. The price increase was ridiculous. It was like another, I don't know, $1,400. It's like, oh, you want to go from 1 terabyte to 2 terabytes? No problem.
Double that price?
We'll just double the price of the laptop. We're going to need you to donate an organ. So we keep wanting more and more and more and more. So the same thing goes with our video games today. So if we roll back and we say a video game that looked great 10 years ago, no longer stands up to our current standards, right? Isn't that even kind of the thing with what's the name of this game I'm playing? I'm gonna play Skyrim. So Skyrim came out years ago, right?
2011.
Huh? 2011. Okay. So since 2011, so this is 5-6 years ago, let's say. What's changed in terms of our expectations of what a game should look like is drastic. So I'm guessing in 2011, did Skyrim look awesome? I mean, was it considered to be like bleeding edge then? Or right there, right? It was considered, it looked good. Okay, but now you take the 2011 Skyrim and you put it up to a game that just came out this year that looks good. How does it stack up? I mean, does it look like kids' crayons, or is it not that bad?
They just released an updated.
No, I know that's why I got it. I got the update thing with the new graphics. But I mean, I'm saying if you take the 2011 version and you bought that today, the 2011 graphics, you would be relatively disappointed in the graphics.
It would look like medium settings on any other game, I think.
Okay, gotcha. So it maxed out would be medium settings on something else. So we keep wanting more and more and more, which then requires us to have more hardware to drive it. Okay, and you talked about rendering textures earlier, which is going to deal with decompressing images, getting images up on the screen, coloring all those, driving these monitors, these 4K monitors, let's say, where each pixel needs to be turned on, and these monitors have different pixel densities. So, the more pixels, the smaller the monitor, and the higher the resolution, the tighter the pixel density. So if you're trying to drive a lot of pixels at 60 or 120 frames a second or something like that, in terms of capability of your monitor, then you're going to need a beefier graphics card. What I always thought was funny is if you look at your monitor, how many of you who have gaming machines know the speed of your monitor? Okay, so how is monitor speed rated? Hertz. Okay, so what's the speed of your monitor?
144.
144 hertz. 104. Okay, so that means so how does that translate? What does 144 hertz mean to you?
It means I can get up to 144 frames per second.
Okay, your monitor is capable of displaying 144 frames a second. That's what your monitor can do. Okay, forget about the human eye that's looking at the monitor. Okay, forget about what it can see. Okay, your physical monitor can only show 144 pictures every single second. Right? And what's the resolution of your monitor? Okay, so it's a standard 1080p monitor. What about yours? Okay, but yet you'll try to run games in 4K?
No.
You wouldn't?
What would you gain from that?
Huh?
What would you gain?
It's kind of my point here. But people do this.
I don't think so.
They do.
How would you do that? You just set your resolution from 1920 to 1080p to the 4K resolution?
Yeah, because the thing is that your depending on how you
But that doesn't. But
how
then won't my thing just be like?
no, because your graphics card will quarter the settings.
Yeah,
So I'm back to 1080p.
You're back to 1080p, but based on more data.
Perfect.
So it's the best 1080p you.
When I want my computer to also be a space heater.
That's right. That's right. If you want a reason to get a new monitor, because they have 4K monitors now, right?
Yeah.
you're doing that. It's called super sample.
Say this again.
Oh.
Super sample.
Yep. Yeah. So punchline is and so let's roll back. Now, do any of you have a graphics card that can push 144 frames a second with any sort of consistency?
Depending on the game.
Okay.
Yeah. It should say
Okay. So let's say that you have a graphics card for game XYZ that can push 150 frames a second. Your monitor can show 144 frames a second. your eyes can see 45 frames a second. We starting to see the interesting kind of situation here. Yet, you would get the better graphics card. It's like, well, I mean, I can do 150 frames a second, but this other guy over here, I mean, he runs off a nuclear power source. And he can do 320 frames a second. I bought 2 of them. Okay, so I'm splitting the screen in half. I'm doing effectively 640 frames a second. Okay. Oh, well, that's nice. Well, what can your monitor do? I could do 144 frames a second. Okay. You know, that's like having a Ferrari that can do, 220 miles an hour with tires on it that are rated to 75 miles an hour. Once you get past about 130, your tires just blow off the car, right? So that's the way it works. I mean, I think those sports cars, don't they have just as expensive, relatively expensive tires? They need performance tires for these things that can handle the forces.
No, for GSDMWs, you have to special one for the tires.
Yeah, I mean, I don't think you're walking into Costco and doing their Firestone tire special for your Ferrari. I mean, I don't think that's not going to cut it. I mean, you do that for your like F-150. Right? You go in there and say, I just need big tires. It's like, well, how fast you go? I don't know, 50, 70. I'm pulling a boat. something like that. All right. So human nature is for us to keep pushing the envelope even when it doesn't even make sense. I mean, logic's out the window. It's like, well, what do you need 150 frames a second for if your monitor can only push 144, if your eyes can only see 45?
You keep offending me by saying that.
Why do you need a monitor that can do 144 frames a second?
So that I can feel buttery smoothness. The second I turned that monitor on, and I went
Literally.
swoosh when I looked around. I was like, oh.
I actually just threw it up. I actually just threw up in my mouth a little bit. When he put buttery smoothness together, and something happened. It was a gag reflex. It was weird. so I could
You
feel.
need to feel it on the desktop versus 60. It's amazing.
Oh yeah, for sure.
So you guys are like drinking the same Kool-Aid.
Yeah, dude, I got a brand new Poker 3 mechanical keyboard too. So literally all my feels are amazing. It's just, it's so good.
So let's get Christian worldview in here. Let's talk about worshiping false idols. So it's like, well, I skip church on Sunday to go pick up my gaming keyboard.
But I thank God every time.
The buttery smoothness was just exhilarating. Hey, that's funny. So, do you really need? Well, need is relative, right? Okay, so I think we've already kind of proven that point, right? Okay, but if your human eye can see 45 frames a second, we can experience a little bit more of that with the quote buttery smoothness. So you should get that coined or something. It sounds like it. I mean, it sounds creepy, but it's I get what you mean. Could you get by with a monitor running at 60 hertz?
I was a peasant, sure.
I mean, if I was legally blind, I mean, I have eyes, right? do I mean, because I don't think I need eyes if I have a 60 hertz monitor. I can just do that off of feel.
You go to YouTube right now and Google 1530, 60, 120 FPS comparison. You tell me you can't 100% see the difference.
Well, you have a 60 hertz monitor.
Well,
Yeah, I'm not. Well, and I have bad eyes, so I see like 9 frames a second. That's why I play golf. The ball doesn't move, so that's more my speed. Yeah, you start getting into these things where people throwing things at 100 miles.
Find it after you hit it. Then.
It's actually difficult because I wear trifocals, so I lose as the ball goes. I lose it between my focals, and I have to have people watch. I'm a pretty decent player, so I have a pretty good feel for where I hit it, but I don't see it a lot of times. It's bad.
They have like GPS injected golf balls yet?
I think somebody makes them, but nobody plays them. I mean,
It's because it messes up.
I mean, you're dealing with some like pretty heavy forces when you know are having a big piece of metal slammed into the ball and sending the ball off at 160 miles an hour. Yeah, the radio's not going to hold up real long. Is kind of how I would think it is. They also have some things that deal with like I think there's some golf balls that are coated with a special thing where you actually use I don't know if it's just an app or a camera thing that comes with it that will pick it up like in long grass and stuff. Even if it's just like one little speck, it'll detect the ball. But I just go to lostgolfballs.com and buy previously used golf balls. So if you don't find one, you just drop one where you think you hit it and keep going. You're out 15 cents.
Lostgolfballs.com.
Mhm.
That's actually where you get your golf balls?
Yeah. I play good golf balls. So I play like TaylorMade tour balls. They're like, $60 a dozen golf balls, but I buy 50 of them, 50 balls for maybe $80 because they're probably somebody hit it off the tee once and lost it. And somebody else collected it, sold it to this place, and I buy it from this place. And they're like brand new balls. And I don't even have to take them out of the box. They just give me a big bucket of them. It's great.
You know, like that new shiny.
They are new and shiny.
No. What?
Somebody hit it.
Somebody took it out of the box, put it on a tee, hit it once, lost it. Because you can buy them in different. Like I get the four A ones, the ones that are like basically new golf balls. There's different ratings.
Gotcha.
But why buy new golf balls? I always laugh at the people that go into the pro shop and buy a dozen Titleist Pro V1s for $65.
Yeah, I guess.
And then they go out and lose half the dozen on that round because they suck. Like you shouldn't be playing Pro V1s. You should be playing like Top Flight. There's nothing wrong with Top Flights.
Probably once. So.
Yeah, exactly. You're a golfer, right? What do you play? What ball? What?
I use that same site to get my
Yeah.
balls.
Yeah. So are you a pretty decent player?
I was in high school.
Okay.
I don't play that much anymore.
Okay, but so you have your pecking order. If you find a ball on the course, there's balls that you'll keep.
Yeah.
And then it's like I give my dad the crappy balls, but he finds a Pro V1 or any of the top tier balls from any of those are mine. He gets the crap, the noodles, the Top Flights, and the Wilsons. Although Wilson makes their new staff ball is actually a pretty decent ball. Man, how we get onto that? Oh, 9 frames a second. 9 frames a second. That's where we got there. All right. So point is that we have technology today that outperforms what a human being can experience. Now, I don't disagree with you that if you have something that is maintaining a speed that's so far beyond what a human being can mechanically experience, you might have a perceived quality improvement over something else that's also ahead of where you are, just because there's no flicker. There's not that one little piece of perception that, the human being really can't see on a consistent basis more than 44 or 45 frames a second, but they would notice the difference between 50 and 70 frames a second over a 1 minute period or something like that. That's possible. I mean, these are all more of a perception thing than what we're able to see kind of on average. But we keep pushing the envelope, and just like she asked earlier, is there a point when we don't need higher resolution? We don't need higher pixel density? So what do you think? Are we going to get to this point where we can't get better? I mean, we've kind of talked about that earlier this semester with our hardware, right? That our processor speeds really aren't substantially faster today than they were 3 or 4 years ago. Our internet speeds aren't really substantially faster today than they were 3 or 4 years ago. We're just now starting to see this whole gigabit movement in internet, but it's not prevalent yet. And even when it's out, even the people who have it now, you're still limited on where it benefits you. Fine if you live in a house with 15 other people and you all have Netflix accounts. Where you can maximize 4 streams at a time from each of the 6 Netflix accounts. Maybe you could start pushing your gigabit connection. Maybe, right? But under normal use, a gigabit connection is overkill. It's just going to look great on paper. You're not going to be able to, you know, a family of 4 isn't going to be able to pull or maximize that bandwidth. You know, but it comes down to the whole thing: would you rather have it and not need it than need it and not have it? It's kind of, you know, so would you rather have 144 frames a second and not be able to ever experience 144 frames a second? Or would you rather need 144 frames a second at some point in time? Because isn't that's the thing that gamers do? You buy these bulked up systems with crazy expensive graphics cards and the faster system RAM and the fastest graphics cards and the nicest monitors, all this stuff, and you're not buying those things for the average case. Okay, because on average, when you're playing a game here and somebody else is playing a game here and you're in a somewhat underpopulated area in the game or something like that, they're going to look the same. It's when you walk into the war zone, when there's explosions and everything happening all over the place, and their machine goes down to a crawl. Okay, they can't. The game's unplayable for them. Okay, and you didn't even notice. That's what you're spending the money for, right? For that 15 seconds of was that buttery smoothness, or is this a new adjective? It's all about that. I get it. Okay, so you're paying for that. That's where that performance comes from. All right, so let's kind of tee us up for next time here. So we're going to be talking about a couple of specific technologies and trying to understand how these different things are actually implemented under the hood. And this kind of comes down, we started talking a little bit about it last time, it comes down to this idea of data representation. So this is a theme that keeps coming back up in all sorts of classes in computer science. How do we represent our data? Well, if we're thinking about memory, at the end of the day, what are we trying to do? We're trying to come up with interesting ways of representing and remembering a 0 or a 1. That's it. Okay. Different strategies for remembering a 0 or a 1 over time. And we have different expectations for different memory technologies, right? For your hard drive, you expect it to remember that stuff for a long time, right? When you put something on your hard drive and you turn the computer off, you kind of expect it to be there the next time you turn your computer on. You're going to be upset if it's not, right? Yet, you load something into system RAM, you turn your computer off, you have the expectation that's going to be gone. Next time you turn your computer on, it's going to have to reload the operating system from your solid state drive into RAM and start over. Get a fresh copy of it in RAM. So different technologies work different ways, but at the end of the day, they are all trying to do the same thing. Remember a single 0 or 1 for some amount of time. That makes sense? Okay, so we're going to look at the difference between an SRAM technology, a DRAM technology, and then I'm going to not even talk about the mechanical stuff, but we'll look at how solid state is similar to that and kind of where solid state is likely going to go. Because right now, for those of you who are into the solid state stuff, we're kind of in the infancy of it. You know, solid state keeps getting faster and faster and faster, and it's way faster than the mechanical drive. But I think you're going to see that gap close between system RAM speed today and solid state drive speed tomorrow. I think you're going to see solid state catch up quite a bit. You'll also then see replacements for system RAM, and so it'll get faster as well. But we're just at the beginning of seeing that push in performance. Make sense? All right, I will see everybody on Thursday. No homework, but expect some over the weekend. All right.